All right, let's talk about something that seems almost impossible. How did ancient people build these massive monuments and sprawling trade networks? We're talking about moving incredible weights, literally megatons of material, all without the kind of technology we just take for granted today.
So if I were to ask you, what's the one single invention that made all of that happen? Your mind probably jumps to one thing, right? The wheel. It's got to be the wheel. It's the icon of human progress. But what if I told you that's not the whole story, not even close? What if for thousands of years the wheel wasn't the answer? And for some of the greatest empires on Earth, it was never the answer at all.
You see, ancient engineering wasn't about just waiting for that one eureka moment. No, it was a constant grinding war against the basic laws of physics. The real story here is about a deep understanding of energy and how to overcome the two invisible forces that want to keep everything stuck in place: gravity and friction. So let's start right there with that first big enemy. How in the world did they move stone blocks that weighed tons without a single wheel? Well, the first step was to literally hack the physics of friction. Okay, quick physics refresher, but I promise it's cool. Kinetic friction is basically the villain of our story. It's that dragging, scraping force that fights you every single inch of the way. The higher that friction, the more raw power, more sweat, more energy you have to burn just to get something to budge. Ancient engineers, they were absolute masters at tricking this number. Let's go to Egypt with the pyramids. The challenge is immense, dragging these colossal stone blocks on big wooden sledges right across the desert. But dry sand is a total nightmare. It doesn't act like a solid road, it's more like a thick, sticky liquid. The sledge just digs in, sand piles up in front, and that friction value just goes through the roof. You're not just pulling a block anymore, you're trying to plow the entire desert. So, what was their revolutionary piece of tech? Their big secret? It wasn't a machine, it was a bucket of water. You see this image from the tomb of Jehuti-Hotep with the guy pouring water in front of the sledge? For a long time, historians just thought, oh, that's a religious ritual. Nope, it was high-level applied physics. And here's the absolute genius of it. You don't drench the sand. You just add a tiny, precise amount of water, somewhere between 2 and 5%. What this does is create these tiny little capillary bridges between every grain of sand. It basically locks them together. Instantly, that sticky, fluid-like sand stiffens into a firm, solid surface. The result? The force you need to pull that massive sledge gets cut in half, just like that. It's an unbelievably clever hack. Okay, but that's for a sandy desert. What if you're somewhere else? In Neolithic Europe, the folks building things like Stonehenge had a similar problem, but with a different surface, dragging huge stones over soil and wooden tracks. And their solution was just as brilliant. And the differences made? It's just staggering. I mean, look at these numbers. If you tried to drag a 40-ton block on dry wood, the friction is so high, you'd need something like 2,000 people. But if you grease those tracks with animal fat, the friction absolutely plummets. Now you only need about 200 people. That's a 90% reduction in the workforce. All of a sudden, these giant projects go from being impossible dreams to something you can actually organize and achieve. This wasn't just Stone Age tech, this was organic chemistry in action. So, hacking friction is a game changer. But you still need a power source, right? You need an engine. And for that, ancient societies turned to the very first generation of heavy machinery: animals. The best way to think of it is like a Neolithic garage. You've got two main models. First, you've got the ox. This is your heavy-duty tractor. It's slow, sure, but it produces incredible torque. That's pure pulling power. And its fuel, grass, which is perfect because we can't eat it. Then you have the donkey. The donkey is your nimble, all-terrain pickup truck. It's got a fantastic payload-to-weight ratio, it's tough as nails, and it's great for long-distance hauling over tricky ground. But this introduces a huge logistical problem. These living engines need fuel. A donkey on a long trip has to carry its own food. We're talking about 2 kilos of fodder a day. So for every single day it travels, the amount of actual valuable stuff it can carry goes down. It is, for all intents and purposes, the rocket equation of the ancient world. It meant that for really long-distance trade, you had to focus on goods that were super valuable but didn't weigh much, like metals or textiles, just to make the trip worth it. So you've figured out friction and you've got your living engines. But what if? What if you could almost eliminate friction and gravity from the equation altogether? Well, for that, ancient people turned to the greatest transport network on the planet: water. I mean, just look at the leap in sheer capacity here. One person can carry maybe 50 kilograms. A donkey can handle about 80. But a single, simple Neolithic dugout canoe, it could haul over 1,500 kilograms. That's not just a small step up, it's a massive jump. One boat trip is like sending out a team of 30 people or a caravan of 20 donkeys. Rivers and seas weren't just routes, they were superhighways.
And we are not talking about small-scale local trips. This number, 1,300 tons, that's the estimated amount of obsidian, which is a really valuable volcanic glass, that was quarried on the Greek island of Milos and shipped all over the Aegean. We're looking at a huge, reliable, long-distance maritime trade network, all happening thousands of years ago, powered by nothing more than human muscle and wood.
Which brings us right back to the beginning, right back to our original question. We've seen all this incredible ingenuity, so what about the wheel? Specifically, what was going on in the great empires of the Americas? You know, this has been one of history's great mysteries. Archaeologists have found wheeled toys in Mesoamerica, so they knew the principle, they understood how it worked, but they never scaled it up for transport. Ever. So why? Was it some kind of cultural blind spot? Were they just not inventive enough? No. The answer is way simpler and a whole lot smarter. First, there's the physics of the environment. The wheel is a miracle worker on flat, hard ground, but you take it into the steep, rugged Andes Mountains, and its advantage just evaporates. Suddenly, friction isn't your biggest problem anymore. Gravity is. You now have to physically lift the entire weight of the cart and everything in it straight up a mountain. The famous Inca road system with its thousands of stairs was a masterpiece of engineering for people and llamas on foot, but it would have been totally useless for a cart. And, okay, even if you built perfectly flat roads, what's going to pull the cart? This is the second crucial piece of the puzzle. In Eurasia, you had the ox, a biological tractor. In the Americas, you had the llama. And llamas are amazing animals, but their bodies just aren't built for pulling. You can't put a yoke on them, and they can only carry a pretty light load. There was simply no engine powerful enough to justify the extra weight and complexity of a cart and axle. So when you actually lay it all out, the choice becomes crystal clear. A wheeled cart system needed a powerful engine that they didn't have, and it was designed for flat terrain that they didn't have. Their existing system of human porters, supported by llamas carrying gear, was perfectly adapted to their mountainous world. It was simply the more efficient, more logical, and energetically superior engineering choice. Period. So you see, the absence of the wheel wasn't a failure. It was an active choice. It was a logical rejection of a technology that was a terrible fit for their world. It teaches us that true innovation isn't always about inventing the next new thing. It's about finding the absolute best solution for the unique problems you actually have. And that leaves us with a pretty fascinating thought to chew on. It's so easy for us to look back and judge the past through the lens of our own technology. But the real lesson here is that context is everything. What seems like a brilliant, universal solution in one time and place is a clunky, useless burden in another. Which really makes you wonder, what technologies that we think are absolutely essential today might future generations look back on and see as completely the wrong tool for the job? Thanks for watching.